Next is
I'm next.
space.
The final frontier.
The final frontier. So, guys, on this week came out, a bunch of papers were published because on August 16th or 17th this year, the LIGO Observatory detected gravitational waves emitted from the collision of two neutron stars.
What?
Yeah. So I don't know if you would have heard last year they detected black holes merging, and they managed to actually detect the warping of space due to gravitational waves from two black holes merging with each other about a billion light years away, something like that. Probably happened a billion years ago.
Yeah.
It was actually incredible. It was like groundbreaking stuff. For the entirety of human history, we've only ever been able to look out into the universe, like using our eyes or using telescopes, or more recently we have other detectors that see other electromagnetic radiation. But with this LIGO observatory, you're actually able to see the ripples in space itself that are caused by massive events happening. So this detection is a bit different. So with the black holes, all you can do is see the space-time warping, but you can't point a telescope at the black hole and see anything. There's no other light, there's nothing else coming out of it. With the neutron stars colliding with each other, we actually were able to see all sorts of other detections with other electromagnetic radiation across the spectrum. So we actually got Hubble Space Telescope, looked at it in visible light. Fermi looked at it in gamma radiation. I think the Chandra X-ray telescope looked at it as well. And then we saw it in radio waves. There's a big array of radio telescopes in Australia that were able to look at this explosion.
You have a question?
We've got a couple of questions.
What is a neutron star?
All right. A neutron star is what you get if there's not enough mass to form a black hole after a supernova explosion. So you get a black hole when you have an extremely massive star, more than 20 times the size of the sun.
Oh, that's a big one.
Or 20 or 30 times the size of the mass of the sun.
Blows up.
When it blows up, there's still so much stuff in the core, and it's no longer fusing together anymore, so it doesn't have that radiation pressure that keeps it out. And the gravity is so strong that it just pulls itself in, nothing stops it, and it just keeps going until it's point. And that's a black hole.
How big? Oh, so that's a black hole.
Yeah.
But what if it...
With a neutron star, you get to a spot where everything collapses, and then you get to a point where the electrons get fused with protons, and all you're left with is neutrons. But it doesn't quite have enough mass to overcome something called degeneracy pressure, which is like a quantum physics effect where you can't force these things any closer together. There's a pressure that stops it.
That's how black holes...
That's how you get a neutron star. So there wasn't enough mass to cause a black hole. So between 8 and 20 or 30 solar masses, you get neutron stars. So what they detected was neutron stars, which were in a binary pair. So you had two neutron stars orbiting each other. And because they're so massive and, with this binary pair, they were quite close to each other.
I read that they were not, how massive are they? They're obviously very dense. I read that they were the size of Mount Everest, but with the mass of the sun or something.
They would have had much more than the mass of the sun. So between 8 and 20 times the size of the sun.
It's a lot of mass.
And they would be packed into an object the size of a city.
That's crazy.
I have another question before we continue.
Okay.
So, there's a record number of things looking at this. Why is it still that we have bloody artist interpretations instead of actual video of this?
The actual observations wouldn't look that cool.
Right.
You wouldn't be able to see two things spinning around
Look
each
like
other.
a
You would
graph.
see a flash.
That's it.
Yeah, because you can't...
Because there's no light on it.
Well, they're not that bright until the moment that they come together.
Right.
And you get this massive explosion of matter and stuff flying out.
So a
You see
shiny
this big
neutron
flash.
star isn't an actual thing.
They are bright, just not that bright.
Right.
And they're very
This
far
was
away.
a known binary pair. So the exception to that is these things have a massive magnetic field, and what they do is they actually spew out matter along their axes of this magnetic field. So on opposite sides, there'll be streams of really high energy matter and radiation coming out. and occasionally, and they're spinning around.
Like a spinning top.
Yeah, they're spinning. Oh, not even on a top. Like they'll be spinning on
Oh,
some
okay.
axis, right? It'll be this beam will be like a lighthouse, flashing around in the universe, and occasionally it'll line up with our viewpoint, and we'll see a pulsar. That's what a pulsar is. That's the thing that tricked people when they made SETI, the Search for Extraterrestrial Intelligence. This was like an old NASA project. When they initially saw this pulsar, they thought it was another.
The Martians.
Yeah, they thought it was an extraterrestrial, like intelligent
Signal.
civilization trying to talk to us.
Just a neutron star.
But it was a neutron star.
Star.
Pulsar, actually.
It's all coming together.
Apparently, Thor's hammer was forged in the heart of a neutron star.
Everyone knows that.
Please
Yeah.
treat us like we're naive. The question I had is, so these gravitational waves are quite new, right? It's the
Detecting
detection of
them?
them.
Yeah.
So Einstein predicted them.
Yes, Einstein predicted it in 1911
Yeah.
or something.
Long time.
When he did general relativity, predicts these.
So
these
is everyone like-
gravitational waves.
Yeah, Einstein.
But this was
Everyone's always
Everyone
like,
was
yeah,
kind of
Einstein.
already that, but it's
Yeah.
just like he gets smarter
Yeah.
the longer time goes on.
No, okay. This
Bit like
this
me.
was predicted like ages ago, and people have been like working out. Okay, how are we going to actually detect these things? Because you have to be. The ripples we're talking about are like ridiculously small. Like the accuracy you need to have in order to actually sense this and separate it from all the other rubbish that's going on. Like tapping a table here is so much more like of a vibration than this.
Yeah.
Like so the way they do it is they have this 2.5 mile like laser, like L shape, and they have lasers in both of the arms. Same laser actually. It's an interferometer, and they basically detect the really small variation in the arm lengths as the waves pass through them.
Wow.
Like how cops check the speed of cars. No. They shoot 2 lasers, right? And that's how long it takes for the second one to come back.
I don't know.
Not at all.
That'll
So
be
I
one
thought they
laser,
do
wouldn't it?
radar.
Oh, there you go.
Yeah.
That's right.
Lasers are cool though.
Lasers do this thing where if you like have the same beam and it's on top of itself, it'll have interference patterns, and you can measure a really tiny change in distance by the change in the interference pattern because it's very sensitive.
And also, I read that there was materials that were created from this explosion.
That's
Yes.
the cool stuff, right?
Yeah. So the cool thing is it was able to confirm a lot of like science stuff that they've always thought was happening, but you could never because you don't know when a neutron like star collision is going to happen, so you're not all going to be pointing at the thing when it happens, and you don't know that's what it is that you're looking at. You just see a flash and you're like, oh, what is that? So they were actually able to confirm because they had all this visible light, like Hubble and stuff looking at this event. They were actually able to confirm that most of like everything past like iron, so like gold, platinum, is actually made in these events.
Yeah.
So
Sign me
that,
up.
do you have a gold ring on your
I
finger?
got one.
That material was born when 2 neutron stars collided with themselves.
Bro, it must be worth heaps.
But so is like everything else past iron as well.
Yeah.
I mean,
Yeah, I was going to say, did they just pick that out, or did heaps of things get created?
heaps of things get created.
So is
like,
that anything heavier than iron?
yeah, most of the iron is probably made in red giant stars. So like a star gets big enough to actually produce like iron as like fusion. It's the last thing that fuses before you stop gaining energy out of it. So like the core of a red giant star will be iron.
Yeah.
But in the case of these neutron stars, they actually have like a thin outer shell of iron, and then because they must get like sucked on to the outside. And then in the collision, it just like, because all this matter just spews out, but it's also lots of neutrons, which is exactly what you get in like a nuclear reactor.
Yeah.
That's how they like, when they discover new elements, that's basically what they do. They get a target and they shoot neutrons at it until they can like stick them in there.
Like in Iron Man 2,
Just stick them in
Yeah.
when he creates a new element, right?
Yeah.
there. Sure.
Yeah.
I got analogies for days,
Love
guys.
that.
So what happens to these materials? Like
They just get
these-
spewed out into the universe.
Can we make a big net and
Do
catch
they
them?
form like rings around planets and stuff? Is what the
I
sun-
guess you get some sort of nebula
Yeah.
forming after an
Nebula.
explosion like this. So there would be like remnant nebulas that happen after this, and then like if there's enough material left, it'll all coalesce, and you'll start getting a star forming in the middle, and you might get a solar system around it.
Cool.
Like what we have.
What do we do with now that we got gravity waves?
Well,
Does that
now
help-
we can.
what do we-
Well,
what's that mean?
we need to make. They're making more of these spots on Earth that have these like gravitational wave detectors. So there's 2 in the US and there's 1 in Italy, Virgo. So the 2 are called LIGO and there's 1 called Virgo. There could have been 1 in Australia, but we didn't pony up the dough in 2011.
Far out.
They're building 1 in India.
It's all this Centrelink we're paying out.
They want to build them. Like maybe they'll be able to find the money now because they know it works.
Now we got to pay our morning show hosts.
I don't know how much they cost. I don't know how much it would cost to make a new one because they've kind of figured out how to do it.
It'd be less, right, nowadays.
You'd think so.
Well, microchips just keep getting cheaper, right? So.
Yeah. Probably not giant lasers. Though.
But was there also like a pulse of gamma radiation, gamma waves?
That's how
spirits out, or?
That's how they. So 1.7 seconds after the gravitational wave was detected, they saw a gamma ray flash in Fermi. So.
And Fermi's the name of a.
Fermi is the name of a satellite.
Satellite. Okay.
That like picks up. That's tuned to pick up gamma radiation. And they were able to go. Oh. So we've always thought that these kinds of flashes were neutron stars colliding, but we didn't know that. And they saw this type of flash, and they're like, oh. And then it matched with this gravitational wave detection. They're like, oh. So then they sent out a message to everyone, all the astronomers, going, point your stuff at this location, because Fermi, combined with the LIGO detectors in Virgo, were able to sort of pinpoint where it was happening. And then another telescope managed to like narrow it down, so everyone was pointing their telescopes at it and trying to figure out exactly where it was happening.
It's nice cooperation.
Yeah, and then like Hubble, like, so it's a big deal when they point Hubble at something because it costs a lot of money to do that.
Could they point it at this dude?
Could they see it?
No, there's limits to the resolution in Hubble as well. I don't know if it's big enough. There's a Rayleigh criteria. I think. Yeah.
Oh, Rayleigh got me again.
Yeah.
You didn't answer my question. What do we do with this?
So yeah, I
what
guess.
do we do with this? We learn like heaps about the universe.
Okay.
So
Like
the
heaps.
The question is, so what? For someone who, maybe not interested in science for science sake, maybe thinks it's a waste of money. Are there implications?
People like Trump.
It's hard to say now because obviously, the researchers and the people who are actually working on that.
Yeah.
Is there implication? Do you think? Is there examples of things like this that have meant changes in society?
I don't know. It's always
hard to say.
like, have you heard of any like that you could? I don't think.
I can't think of the top of my head, but I know there'd be implications from the past that things have been discovered that have led to medical breakthroughs or changes in technology that because the implications could be very wide, couldn't they?
Yeah.
Like, because they created things here, could this be the key to making alchemy more of a real thing of like combining things to make new things?
No.
Okay.
Absolutely not.
Like, can we make mini
It's the
neutron
worst
stars? Like, in any way? Like, can we create a mini neutron star? Like,
No, I mean that's what a fusion reactor is trying to do.
right.
Like it just takes lots of energy.
But they just keep exploding, right?
No, it's just that it takes a crazy amount of energy to do that.
Right.
There's not really any point.
Unless we use the
It
sun.
would be way easier to go mine an asteroid than it would be to do alchemy on a big scale.
Mine an asteroid.
Yeah.
Like Armageddon?
Yes. No, that's a meteor.
They weren't trying to mine it, they were trying to blow it up.
What do you get off an asteroid?
Lots of things actually. Apparently, like, there's a website you can go to that tells you the value, monetary value of different asteroids in the asteroid belt.
How do they know
Why?
what's in it,
Because
though?
what
Are they just
They know
guessing?
roughly what it's composed of. Just
Sign
based
me
on
up.
based on the different amounts of material. No, there are people looking into
New mining boom.
mining
Tell
asteroids.
Turnbull.
Asteroids.
So
Are they the ones
space
that are
travel becomes a thing.
zooming past us?
You would go to the asteroid belt where they're in
Ah,
orbit
okay.
around, like,
Yeah.
so there's actually quite large ones there as well.
Well, they seem far
It'll be
away.
like the
Yeah, it's
the
past,
gold rush.
It's past Mars.
It'll be
Seriously?
the asteroid rush.
They'd be robotic missions though. I'd
Ah,
imagine.
okay.
Yeah, probably
You
be
wouldn't
dangerous.
send a
Bruce Willis.
person. There's not really any point.
That's a pretty
There's a movie
ridiculous
in there.
idea for a movie, eh?
But it's pretty cool. It's fascinating.
close my eyes.
But I guess we'll wait and see. What,
Like, how
what
can there
leans
not
on.
be
I
smarter people who know how to mine a friggin' rock?
I will. Yeah, that's true. They will. Okay, if we're ever gonna, if there is something out there like using dark energy to travel faster than light, this is the route you have to take because this is telling us about how the universe works. This is confirming theories or showing that they're wrong about because at this point, if you look far enough away and you're looking at gravity, you're starting to confirm or just like dispute theories that we have about the way the universe actually works. If
Crazy.
you can work out that stuff, and if you can nail it down, you can start to work out, oh, maybe we can use these things.
Yeah.
So even if you're the kind of person who's like, I don't care about stars, you
Yeah.
should still think, all right, we might not see it in our lifetimes, but this is a step in the process of
Yeah.
like getting something awesome.
And
Like
you're
people who
crazy.
invented the cathode ray tube didn't see TVs,
No.
but that was the technology required. The reason they were doing it was to investigate how electrons worked, and no one cared about electrons back
Yeah,
then. Like
yeah.
not a normal person. They're
Yeah.
just using a steam engine to produce power. They don't care. Oh, what's the mass of an electron or something like that, or is it a wave or is it a particle? No one would have cared. But that's the fundamental stuff you need to make semiconductors work. It's like the underpinning of all our technology today.
So care about the stars.
Because we don't
Care
know
about
what
science.
We don't know what it could lead to.
No,
Final
Huge
thoughts.
breakthroughs for us.
that's the point. This is awesome. This is like a new era.
Yeah.
Is it as important
Exciting.
as TV hosts getting paid money?
Should these scientists be paid more than probably
Probably
Definitely.
not as important as gender pay parity.
Ooh, okay.
They probably get paid a lot less though, right? Doesn't that suck?
definitely
Then what? TV hosts?
These are the rock
Yeah.
stars that should be getting paid.
Good perspective.
probably like 10
Jono.
times less a year.
Okay.